when you are going to derive two function in the form of f of x plus g of x, derive them separately. First function into derivative of second plus second function into derivative of the first. So this rule is called as the product rule. Here v, u, v square will be in the original form. Only du by dx and dv by dx will be the derivative of the given function. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So welcome to the second session of the chapter Differential Calculus. In our previous session, we have learned how to derive the derivative of a function using first principle. So all those standard derivatives is necessary to learn so that we can use it while solving the problems. In today's session, we will be discussing algebra of derivatives of functions. So what do you mean by algebra of derivative of a function? So that is how we can derive the function whenever it is given in a combined form using plus, minus, multiplication or division form, that is quotient form. So here we have a theorem, or you can see it as an important note that how we can derive or write the derivative of any two function when it applies in any one of the form. So the first one is derivatives of sum of two function is the sum of the derivatives of two function. So that is when you are going to derive two function in the form of f of x plus g of x, derive them separately. So apply the derivative for the first function separately and apply the derivative for the second function separately. Similarly, when you are deriving in the form of difference, the same concept, derive the first function separately minus derive the second function separately. The next one, derivative of the two function when it is in the product form. This is also called as product rule. Now, how product rule is defined? So, when you have two functions in the form of product f of x into g of x, then the rule says you should write it in the form of f of x, derive the second plus second and derive the first function. That is, keep the first function as it is, derive only the second, plus keep the second function as it is, derive the first function. First function into derivative of second plus second function into derivative of the first. So this rule is called as the product rule. The next one is what happens when you are going to derive the function in the form of f of x by g of x, provided the denominator must not be equal to 0. So this rule is called the quotient rule, and what does the quotient rule implies? That g of x is the denominator, that is I'll call it as a second function, f of x is the first function. Second function, derive the first minus first function, derive the second divided by square of the second function. So this is how you are going to apply the rule when you are going to derive a functions. These algebra of derivatives can also be simplified using only two terms, that is u and v, where u is one function, v is another function. So some more difference rule, that is when you are deriving the two functions, u in the form of plus or minus, then it is u into dv by dx plus v into du by dx. Now, these algebra of derivatives can also be write in the form of these rules. Instead of f of x and g of x, we are using just u and v. So, whenever you have two function in the form of plus or minus, derive u separately, derive v separately. That is, you can derive the function separately. And the product rule can be written as d by dx of u into v, that is u into dv by dx plus v into du by dx. First function derive second plus second function derive first. Similarly, when you have three functions which is in the rule of product, you can write it as uv dw by dx, uw dv by dx, vw du by dx. That is, keep the function as it is and derive only the function which is not in its original form. Similarly, the quotient rule in the form of u by v can be written as v into du by dx minus u into dv by dx v square. Here v, u, v square will be in the original form. Only du by dx and dv by dx will be the derivative of the given function. Now, let's take few problems using these rules. Differentiate the following with respect to x. The first function is x power e power x plus e power e. Before deriving any function, we should know the list of derivatives. For constant, it is 0. For x, it is 1. X power n into x power n minus 1. Sin x is cos x. E power x is e power x. Log x is 1 by x. Similarly, for other trigonometric function, we have a list of derivatives. You should learn it for the problems. Now we have x power e. So what are the formulas here we have used is x power n. Suppose y is in the form of x power n, then dy by dx is n into x power n minus 1. For e power x, it is e power x only. For any constant, it is 0. So now we are writing dy by dx here. We have x power e. So for x power e, it is e power x to the power e minus 1 plus, derive the second function separately, e power x is e power x only. And the third function is constant. E is constant, e power e is also constant, and the derivative of any constant function is 0. So therefore, the answer is e into x power e minus 1 plus e power x. So this is the derivative of the given function. The next one, we have 5 e power x minus log x 3 root x. So whenever you have a constant multiplied with the function, write the constant as it is, derive only the function. So let's write dy by dx for this function. So I have 5 e power x, write 5 as it is. What is the derivative of e power x? It is e power x only, minus, what is the derivative of log function? It is in the form of 1 by x. So log x is 1 by x. Again minus 3. What is the derivative of root x? It is 1 by 2 root x. So now when you multiply, it becomes 5 e power x minus 1 by x minus 3 by 2 root x. So this is the derivative of the given function. Next we have differentiate the following with respect to use by product rule. So here we are going to apply the product rule. So what does the product rule says? That is d by dx of uv can be written as u into dv by dx plus v into du by dx. So now let us write in this form. So here dy by dx can be written as, so x power 9 into d by dx of 9x plus 9x into d by dx of x power 9. So first function derive second plus second function derive the first. Now I'll write as it is. Here we have 9 into x. So when you have any constant, write the constant as it is. Derivative of x is 1. So it is 9 into 1. Next here we have 9x. And if you have x power n, it is n into x power n minus 1. The power decreases by 1 here. So if it is x power 9, then it is 9 into x power 8. So that is the derivative. So here it is 9 into x to the power 8. Now multiply, here it is 9 into x power 9 plus 81 x power 9. So here 9x power 9, 81 x power 9 becomes 90 x power 9. So this is the derivative of the given function. So next I have secant x into tan x. Apply the product rule, that is dy by dx is equal to first function into derive second, that is d by dx of tan x plus second function into derive the first, that is secant x. Now write secant x as it is. Derivative of tan is secant square x plus tan x. Derivative of secant x is secant x tan x. So now what is common here? You can see we have secant x as a common factor here. So secant x, if I take as a common factor, it is secant square x plus tan square x. So this is the answer. So next one, cot x root 3 minus 4 e power x. You can see this as a first function and the remainder as a second function. So now dy by dx is equal to first function into derivative of the second, that is root 3 minus 4 e power x plus root 3 minus 4 e power x into d by dx of the first function, that is cot x. Now let us derive it. So cot x, here we have to derive it separately because it is in the form of difference. Derivative of root 3 is 0 and we have minus here. 4 e power x, 4 is a constant. Derivative of e power x is e power x itself. Next we have here root 3 minus 4 e power x. Derivative of cot function is minus cosecant square x. So on solving this, here minus 4 e power x cot x, and here you can write minus root 3 cosecant square x, minus into minus plus 4 e power x cosecant square x. So this is the answer. Next question, we have x power 5 into 3 minus 6 x power minus 9. Here we can multiply x power 5 inside, then solve it, or you can use the product rule also. So let me write this in the form of 3 into x power 5 minus 6. We have 2x power 5 minus 9, which becomes 3x power 5 minus 6 x power minus 4. So now we can derive it. So if this is equal to y, then dy by dx is equal to 3 into x power 5 can be written as 5x power 4 minus 6. X power minus 4 can be written as minus x to the power minus 5. Why minus 5 here? Because if you have x power minus n, then it is minus n x to the power minus n minus 1, which is minus n x to the power minus of n plus 1. So if you have a negative power, the value here will be plus 1. So therefore it is minus of minus 4 minus 1, which is minus 5. Now you can multiply. Here it is 15x power 4 plus 20x to the power minus 5. So either you can do like this or you can apply the product rule. So product rule is dy by dx is first function into derive the second, that is 3 minus 6x to the power minus 9 plus 3 minus x6 to the power minus 9 into derive the first function, that is x power 5. So here you can write x power 5, derivative of 3 is 0 and here it is 6. Minus 9 becomes, so minus 6 into minus 9 x to the power minus 10 plus 3 minus 6x to the power minus 9 and here it is 5x to the power 4. So when you multiply this is minus into minus plus, so 54 x to the power 5 minus 10, next here plus 15 x power 4, next minus 30 x power minus 9 plus 4, which will be 54 x power minus 5 plus 15 x power 4 minus 30 x power minus 5. So that will be equal to 24x to the power minus 5 plus 15 x power 4. So you can compare the result. So this is 24, which is 6 4s are 24. So which is same as the previous one. So you can multiply, then solve, or using product rule also you can solve. Next we have differentiate the following with respect to x by quotient rule. So here we have cos x plus sin x divided by cos x minus sin x. So let me apply the quotient rule. What does my quotient rule says? When it is in the form of u by v, d by dx of u by v can be written as v into du by dx minus u into dv by dx divided by v square. So therefore I can write this as dy by dx is equal to cos x plus sin x derivative of, so here it is minus, so minus this is v into du by dx of this minus, so u we have to take, that is cos x plus sin x into d by dx of v, that is cos x minus sin x whole divided by v square, that is cos x minus sin x whole square. Now let us solve this. That is equal to cos x minus sin x into derivative of cos is minus sin x and derivative of sin is cos x. Similarly, here we have cos x plus sin x into derivative of cos is minus sin x, derivative of minus sin is cos x. So here we have cos x minus sin x whole square. Now here you can see this is cos x minus sin x, cos x minus sin x, that is cos x minus sin x whole square. You can write it as cos square x plus sin square x minus 2 sin x cos x. Similarly, if you take minus outside here, so this is cos x plus sin x, cos x plus sin x, cos x plus sin x whole square. So here you can write this as cos square x plus sin square x plus 2 sin x cos x whole divided by cos x minus sin x whole square. Now this is the trigonometric identity whose value is 1. Here also the trigonometric identity whose value is 1. Minus 2 sin x cos x and minus 2 sin x cos x, 2 sin x cos x. So this get cancels here and here we are left with 1 plus 1, that is 2 divided by cos x minus sin x whole square. So this is the derivative of the given function using quotient rule. So next question, 4 into 2 power 6 log to the power 2x. So now let's see what is this. So we have an identity, that is a to the power log x to base a will be equal to x. Now here this is of the form 4 into 2 to the power 6 log x to base 2. Now we have 6 which we can write. We know the formula, that is m into log n can be written as log n to the power m. So I can write this as 4 into 2 to the power log to base 2 x power 6. Now as I said, since from this equation whatever the value of x I have here, I can write this. So this will be equal to 4 into x to the power 6. Now I have y is equal to 4 into x to the power 6. So what is dy by dx now? Dy by dx will be equal to 4 into 6 to the power x power 5, that is 24 x to the power 5. Next question, we have root 1 minus cos 2x divided by root 1 plus cos 2x. So here we have cos 2x formula, that is 1 minus 2 sine square x. So if I shift these two, then it is 2 sine square x is equal to 1 minus cos 2x. Similarly, I have cos 2x is equal to 2 cos square x minus 1. So if I shift 1 this to that side, then 2 cos square x will be equal to 1 plus cos 2x. So therefore 1 plus cos 2x can be written as 2 cos square x, 1 minus cos 2x can be written as 2 sine square x. So applying here, we get 2 sine square x divided by 2 cos square x. Within the square root, 2 and 2 get cancelled. The value is root of tan square x. So that is equal to tan x, because square and square root get cancelled. If this is my y, then what is dy by dx? Derivative of tan x is secant square x. So the value is secant square x. Next I have cos x divided by 1 plus sin x. Let me apply the quotient rule here. So what does the quotient rule says? Dy by dx. So this is in the form of u by v. So the rule says v du by dx. That is 1 plus sin x into d by dx of cos x minus cos x into d by dx of 1 plus sin x whole divided by v square, that is 1 plus sin x whole square. Now the answer is 1 plus sin x. Derivative of cos is minus sin x. And here we have cos x. Derivative of 1, which is a constant, it is 0. Derivative of sin is cos x whole divided by 1 plus sin x whole square. Now here we can multiply this as minus sin x minus sin square x minus cos square x whole divided by 1 plus sin x whole square. Now if you take minus common, this becomes sin square x plus cos square x, whose value is 1. So minus sin x minus 1 divided by 1 plus sin x whole square. Again, if you take minus common factor, it is 1 plus sin x divided by 1 plus sin x whole square. It get cancels. So the value is minus 1 by 1 plus sin x. So this is the derivative of the given function. So we'll continue with few more problems on derivatives in our next session. Until then, keep watching, keep learning and keep exploring. Thank you.